All right, today we are going to work on simplifying under radicals, but not having something that's perfect. All right, so just for a normal square root, and I think if you're not familiar with these numbers, this lovely little yellow piece of paper is going to come in super handy if you need this. So I want to find, to break these down, biggest perfect square that would divide into 45. So on that list in that square root column, the second column there, biggest square root that's a perfect square that would go into 45 would be 9. So I would just rewrite that real quick. It has to be a product, has to be multiplication, 9 times 5. And then you guys know square root of 9 is 3. 5 stays under the square root. That is simplest radical form. Now, if you're working with a cube root, I need numbers out of that third column. So if you're not sure, you can just literally take 250, like divide by 8, divide by 27, divide by 64. See which one goes in. If you do 250, the biggest number on that list that'll divide in would be 125. So I'm going to rewrite this. This is a cube root. I would do 125 times 2. And then if you're looking at the list of cube roots here, the 125, it's the fifth one down, so that root would be 5. So 125, pull this out, is a 5, and then you'd have a 2 left underneath, so it'd be 5, and then cube roots of 2. Try not to forget to put the index. I'll sometimes do that. All right, if you're doing a fourth, we're going to do 48. So if I'm doing a fourth root, look in the fourth column. All right, 16 is actually, 81 would be too much, so 16 is all it is. If you divide 48 by 16, should be 16 times 3. And then the perfect fourth, the fourth root of 16, that's going to come out as a 2. And then left under that fourth root is a 3. So that's what you want to do. Find the biggest, perfect, whatever, and then go from there. Okay, now with variables. I got a bunch of different examples here just to show you different ways that this could shake out. Remember, the index of a root that doesn't have one written in, it's going to be a square root, so that's going to be 2. Okay, so I need my exponent for a square root to be divisible by 2 to take out any perfect squares. So what I try to do, I want the biggest even exponent out of 3. And so the biggest even exponent, I'm just going to use my exponent properties here to rewrite this, out of 3, that would divide into 2 would just be x squared. So I just rewrite that really quick as x squared times x. So x squared times x, if I put it back together, that's using the exponent properties, we would just add those exponents. That would be back to x to the third. I'm just trying to remove any perfect squares. And a perfect square with a variable is going to be an exponent that's divisible by 2. So square root x squared, 2 divided by 2, this would pull an x out in front, and this x would be left underneath. So it would be x times the square root of x to simplify that. Another way you could do that, I'll do it on the next question. I'll show you 2 ways to do this. So again, this is a square root. So I try to think, okay, out of 9, what is the biggest number out of 9 that 2 would go into? And that would be 8. So I would rewrite that as x to the 8th times x. And then exponent divided by the root. If it's even under a square root, it's a perfect square. This would come out as x to the 4th, and you would have this 1x left underneath. Let me just give you one other option. If you would prefer, you could do it like this too. So I'm going to take and I'm going to divide my exponent, which is 9, by the index of my root, which is 2. Just literal long division. Okay, so 2 goes into 9. 4 times 2 is 8, and my remainder would be 1. If you have it that way, that whatever it goes in on the top, that's the power on the outside, whatever the remainder is, that's how many x's would be left underneath. So this is x to the 4th with a remainder of 1. So if you want to do it like that, I'll try that on a couple of questions. Okay, so if I think about this one, I need my exponent to be divisible by 3. So out of 5, I would rewrite that as x cubed times x squared. Or I would think about, if I divided 5 by 3, we could pull 1x out here. Sorry, I forgot to put the index of the root. This is a cube root. 3 divided by 3, this would come out as an x. And then there would be 2 or x squared left under the cube root. So if you actually divided there 3 into 5, this would go 1 time. 1 times 3 is 3, and the remainder is 2. So I pulled 1x out, and then there was 2x squared left underneath. That's another way you could do that. So I'm just going to try to do both for a couple of these here. All right, so 16, out of 16, I need my exponent divisible by 3. Let's see, biggest thing I could do for that would be 15 and 1. So that would go back to be x to the 16th. X to the 15th, this is a perfect cube. Oh my gosh, I forgot that index again. I always do that. So this is a third root. 15 divided by 3, this would come out as x to the 5th. And 1x left under the cube root would be my answer. If you want to actually divide that, 3 into 16, 3 goes into 16 5 times, and with 1 as a remainder. So I have x to the 5th out in front and x to the 1st left underneath. So whichever method you like better, go ahead and do that. I'm going to keep going with the biggest perfect square that goes in. So if I'm working with a 4th root, I need my exponent to be divisible by 4. So I would break that apart into 8 and 3. You want the biggest number up to 11 that 4 could go into. Exponent divided by the root, this would be x squared, and then the 4th root of x to the 3rd left underneath. If you wanted to do it with the actual division, like I was doing on some of those other questions, 4 goes into 11 twice. 2 times 4 is 8. 3 is the remainder. So x squared is out in front. There's 3 x's, or x to the 3rd left underneath. All right, if I do the next one, 4th root for 15. Out of 15, I think it's just going to be 12. So we'd have 12 and 3. 4th root of x to the 12th, that's a perfect fourth. This would come out as x to the 3rd. And then left underneath, I would also have x to the 3rd. If I keep going here, 12. So if I want to do a 5th root, I need my exponent to be divisible by 5. So up to 12, the biggest number 5 would go into would be 10. So I would rewrite that as 10 and 2 real quick. Oh my gosh, I forgot my index again. Here's 5. All right, index, or root. The exponent divided by the index of the root, this would come out as x squared, and that x squared would be left underneath. If your exponent is smaller than the index of the root, like on all these questions, you could go back and look. So 2 is smaller than 5, 3 is smaller than 4, 3 is smaller than 4. If the exponent is smaller than the index, then you know that you've simplified as much as you can. All right, I'm going to do one more. So 5th root up to 24. Biggest x that would go, or biggest number that's divisible by 5 there would be 20. So I would rewrite that just using my exponent properties. If I put those back together, we'd add the exponents. So I'm trying to get an exponent divisible by 5. So this would come out as x to the 4th, and then left under the 5th root, this is also x to the 4th for this question. Now, as long as that exponent is smaller than the index, you should be good to go. What we're going to move on to down here, pause this at any time if I'm going too fast. We're going to actually combine the numbers and the variables. So with the number, if we're working with a square root, I want the biggest perfect square that divides into 45. So we actually did 45 up at the top. So I'm just going to rewrite that again, 9 times 5. For the variable, I'm going to get the biggest number up to 7 that would be divisible by 2. So 6 and 1 is how I would break that apart. If you have an even exponent under a square root, you got a perfect square. So let's take out the perfect square. So square root of 9 is 3. Square root of x squared is x cubed. So then out in front, we'd have 3x cubed, and left under the square root, we would have the 5x. And as you guys do these problems, some of them look really like complicated when you're done, but don't think you're doing something wrong, because that's just sometimes all you can do to simplify some of these problems. All right, now, not maybe as super familiar with perfect cubes. So I'm just going to pull this paper up so you guys can see it. So on my list of perfect cubes, I'm trying to find a number that would divide into 80. And you can check, but on this list, really only the biggest number that will go in will be 8. So I'm going to rewrite this as 8 times 10. And then my exponent, there's 8. So that's not divisible by 3, so not a perfect cube. So out of 8, biggest number that 3 would go into would be 6. So I'm going to break that apart and write that as n to the 6 times n squared. Still n to the 8th. I'm just trying to get an exponent as big as I can that we could divide by 3. All right, from there. Now we're working with the cube root. So the cube root of 8 is 2. 10's going to stay underneath. N to the 6th would come out as n squared. This n squared, that exponent is smaller than the index of the root, so that's going to stay underneath. So we would have 2n squared left under our cube root, 10n squared, and that would be our answer. Okay, now I tried to put these together so these are just the specific type of root. So these two are both square roots, so we're just practicing this. So for 72, and there's several numbers on this list that go into 72, but the biggest number on your list of perfect squares that's going to divide into 72 is 36. And you could always just, take your calculator, be like, okay, what's 72 divided by 4? What's 72 divided by 9? If it goes into those, I would keep going and try and find the biggest number on that list that'll divide into 72, which would be 36. Now, my a to the third, I'm going to break apart as a squared times a, because we're working with a square root, so I need my exponent divisible by 2. Out of 3, biggest number 2 would go into would be 2. I will leave the b alone. That's already written in a format that's a perfect square because that exponent is already divisible by 2, which is the index of our root, so we're good. So square root of 36 is 6. A squared is going to come out as an a. B to the 4th exponent divided by that index of the root, that would be b squared. So then my actual answer, 6ab squared, and then left under the square root, excuse me, would be the 2 here and the a here. All right, 108, I wasn't trying to use the same number, but I guess I did here. Biggest number on that list that'll divide into 108 is 36 again, but it's 36 times 3. And again, if you're not sure, here, I'm just going to pull my calculator up for a second. So like I just divide, okay, 108 divided by 4. Okay, that goes in, but if the result you get is also divisible by a perfect square, like 27 is divisible by 9, then you didn't get the biggest number. So if I divide by 9, like it goes in, but 12 is also divisible by 9. So if I do 108 divide by 16, now that doesn't go in. 108 divide by 25, that doesn't go in. 108 divide by 36, that does go in. And in that case, as long as the other number is not divisible by a perfect square, like 3 is not divisible by another perfect square, you got the biggest combination. So it's really easy to grab your calculator to check these. Okay, now x to the 5th, not a perfect square in the variable land because it's not divisible by 2. So up to 5, the biggest number that 2 would go into would be 4. So I'm going to break that x to the 5th into 2 pieces, x to the 4th times x to the 1st. The y squared, let's just leave that alone because that's already a perfect square because that exponent is divisible by 2, which is the index of the root. So we're going to pull out a 6, the square root of 36. X to the 4th is going to come out as x squared. Y squared would come out as a plain y, just dividing the exponent by the root. So this would be 6x squared y. And then left under the square root, I still have a 3 and I have an x because these were not perfect squares. And I'm going to flip this over to the back. Okay, now you can do a negative number under a cube root. Let me lay that little paper up there so y'all can see that. So 24, biggest perfect square that's going to go into 24, or sorry, perfect cube, my fault, is going to be 8. So I usually just attach the negative to the perfect cube, square, whatever we're working with cube here. So this is 8 times 3. Now, x to the 4th, that's not a perfect cube, so I'm going to break that apart. Out of 4, biggest number 3 would go into is 3. So I would rewrite that as x cubed times x to the 1st. Okay, now, cube root of a negative number is going to be a negative number. So I'm going to pull out negative 2. X to the 3rd will just pull out an x, and everything else is left underneath. So negative 2x, and then left under your cube root, you have a 3x, and then you're done. All right, 54. So, list of perfect cubes, right? You only have a couple to check. 54, I know this is not true, but I'm just going to show you. 54 is not divisible by 8. It's going to give you a decimal. 54 divided by 27, that is something that you can do. So 27 times 2. So under my cube root here, 27 times 2 to rewrite 54. Now, A and B, neither one of these are perfect cubes, so I'm going to break them both up. So up to 7, biggest number that 3 would go into would be 6, and up to 11, biggest number 3 would go into would be 9. All right, so this is still 8 to the 7th. I'm just breaking it apart to take any perfect cubes, and a perfect cube means my exponent's divisible by 3. And then 9 and 2, that adds up back up to 11. We're just trying to remove any perfect cubes. So 27 is going to come out, cube root is 3. Exponent divided by the index of the root, this would be a squared, b to the 3rd, and then everybody else has to stay underneath. So this should be 3a squared b to the 3rd. And then left under your cube root, you have a 2, you have an a, and you have a b squared, because the numbers and then neither one of the variables were perfect cubes there. So that one's really complicated looking. And then this last example here, we're going to move on and do 4th root. So I'm going to look at the 4th column. Okay, 162, there's not really too many to check because 256 would be too big, so I just have 2 numbers to check. So I'm going to do 162 divided by 16. Nope. 162 divided by 81. There we go. So 162 is 81 times 2. So under my 4th root here, 81 times 2. Now I need an exponent divisible by 4. So x to the 5th is not perfect 4th, but if I go x to the 4th times x, or x to the 1st, you don't have to put the 1. That's going to let me remove any perfect 4th roots. And then 36 for my exponent on y, I'm going to leave that alone. That's a perfect 4th because 36 is divisible by 4. So now, and don't get confused with these. We're working with the 4th root. The 4th root of 81 is 3. X to the 4th would come out as x. Y to the 36 would come out, exponent divided by the root, as y to the 9th. All right, so we're going to have 3x y to the 9th, and then still under our 4th root, we have a 2 and we have an x. And then I got one more. So 64 is the number. So if I'm working with the 4ths, really the only number I can check is 16 because 81's too big. So it must be 16. So 64 divided by 16 for sure. 16 times 4. All right, so we're going to rewrite this under a 4th root. 16 times 4. Okay, now x to the 7th. So I'm going to break that apart. 4 is actually up to 7, the biggest number that 4 will divide into. So we got to break that apart, 4 and 3. Y to the 12th, we're going to leave that alone because 12 is divisible by 4. Now we're doing a 4th root of 16. So this is 2. That's 2 to the 4th power. So we're pulling out a 2. This would pull out an x. This would pull out y to the 3rd. And then everything else is left underneath. So 2xy cubed. And then 4th root, 4 and x to the 3rd. As long as that exponent is smaller than the index of the root, you took out as much as you could for the variables. All right, now down here at the bottom, we're just going to kind of do the same thing, but we're going to review one more step, which is multiplication. You can always multiply the same type of root together. They don't have to be the same underneath. We're just going to literally multiply the numbers together and then see if we can break it down. So for my first little review example here, these are both under a square root. Square root of 5 times square root of 10. You literally just do 5 times 10, which is 50. And then if you can, biggest perfect square that goes into 50 would be 25. So I would just rewrite that real quick, 25 times 2. So square root of 25 is 5. The 2 would stay underneath. So this would be 5 roots of 2. All simplified. If you have numbers on the outside, like I have negative 2 roots of 8 and 5 roots of 10 here, just multiply the numbers together on the outside. So negative 2 times 5 is negative 10. That'll be on the outside. And then we're going to squish the square roots together. 8 times 10 is 80. And then we're going to break that up. Biggest perfect square that goes into 80 is 16. So it's 16 times 5. And if you already have something in front, if you pull something out, like I'm going to take the square root of 16, that's 4, If something already exists out here, I have this negative 10, you're just going to multiply them together. So negative 10 times 4 would be negative 40, and then we have the 5 left under the square root for that one. And then I have one more. I've got a cube root. Both of these are cube roots. So squishes together the same way. So we're going to do cube root, and then I'm going to do negative 16 times 32, which is negative 512. And I don't know if you guys know this, so I'm going to pull this lovely little paper back so you can see it. But under the cube root category, 512 is actually on the list. It's a perfect cube. You can do the odd root of a negative number. This would actually just be negative 8. If you do negative 8 to the third power, it's negative 512. So negative 8 would be your answer here. Now, with the variables, we're going to mix that in here at the bottom. We're going to do the same thing. We're going to multiply the numbers. So these first two are under cube root. I'm going to do, 54 times 5. So that's 270. And now what you got to do with the variables, you got to add the exponents on the letters that are the same. So I'm multiplying the numbers, m squared, m to the third, m to the fifth. Okay, I would put them together first and then break it apart from there. Now, under a cube root, biggest perfect cube that's going to go into 270 is going to be 27. So 27 times 10, and then I'm actually going to break that variable back apart. We're going to do 3 and 2. Remove any perfect cubes. Cube root of 27 is 3. Cube root, exponent divided by the root, that would come out as m. So we would have 3m, and then left under the cube root, 10m squared. Question like this, if you have numbers outside, we're going to go ahead and multiply them together. 3 times 2 out in front is going to be 6. And then underneath, these are square roots. We're going to multiply the numbers, so 7 times 21, which is 147. And I'm going to add the exponents on the letters that are the same. So x to the third, x to the third, x to the sixth, and then we have y to the ninth. Now, this is the square root, so for this guy, you have a 6 out in front. 147 is 49 times 3. Biggest perfect square that divides into 49. Okay, x to the 6th, this is a square root, so I'm going to leave that alone. Y to the 9th, though, I got to break that apart. Out of 9, biggest number that the index of 2 would go into would be 8. And then I'd have 1 left. So we're going to pull out a 7 from the square root of 49. Square root of x to the 6th would come out as x to the 3rd. Y to the 8th would come out as y to the 4th. Now, anything that's already out here, the 6 in this question, we're going to multiply that with everything we pulled out. So 6 times 7 is 42. X cubed, y to the 4th. And then left underneath the square root, we have a 3. And then we had a y down there as well. All right, and do 2 more real quick. If you want to pause and try these on your own, you're welcome to do that. I'm going to go ahead and put them together. So multiply your numbers. So I'm going to take negative 50 times 5 here, which is negative 250. So that's my numbers. And we're going to add exponents on the letters that are the same. 1x here, 6 here. We got 7 total if we multiply those together. 9y's here, 3 here, so 12 total if we add those up. Now, on the perfect cubes, biggest perfect cube that would go into 250, I think we did this on the fronts, it's 25. I'm going to write it as negative 125 times 3. Now, my exponents are x. 7 is not divisible by 3, so I would do 6 and 1, 6 being the biggest number up to 7 that'll go and be divisible by 3. Why 12? Let's just leave that alone because 12 is divisible by 3. Now, cube root, negative number, you can do this. This is going to come out as a negative 5. X to the 6th comes out as x squared when we take the cube root, and y to the 12th would come out as y to the 4th. So out in front, negative 5x squared y to the 4th, and then left under our cube root, we've got a 3, and we've got an x. And then I got one more problem. This is a 4th root. All right, so multiply the numbers. 8 times 2 is 16. Add the exponents on the letters that are the same. So 1p here, 2 here, 3 total. 10 q's here, 14 here, so that would be 24 total. Now, this question's actually really quick, so if you're looking at your fourth column here, 16 is a perfect fourth. So this is just going to come right on out as a 2. Now, p to the third, this exponent 3 is smaller than this root, so I can't take any p's out. I don't have a big enough exponent, so that's just going to stay underneath. And the q, 24 is already divisible by 4, so we're just going to do 24 divided by 4 to remove that. That would be q to the 6. So there's nothing to really break down in that question. Just 2q to the 6 out in front, and then left under the fourth root, p to the third.